So to start with, can we like have like a kind of yes, we are only three. Okay. Can we have like kind of review of the project so far? Probably there are among the three of us here, probably there are some persons who are having difficulties or who want to share some kind of technical issue. Okay, so we can actually you can bring that up in the next 15 minutes so that we can tackle the issue.
Sorry,
Are we together,
I
guys?
missed the magic file part. So I think we can do it.
Okay, magic fire for yesterday.
Yes, man.
Okay.
Can just
You're
do
welcome,
it.
Brendan. Okay. Magic file. It's just so painful that yesterday the recording did not actually. I don't know. I can't even say anything. So okay, let's start with that. So magic file. There was a an article yesterday that I was able to I use as a guide to explain it. So let me start with that. Um, okay. I share my screen now. All right. So here we are. So basically, magic files. What are magic files? What are they used for? Magic file, just like we said yesterday, magic files are actually is some kind of file that are used to detect type of a particular file based on their content. Okay. For example, we know that there is this file command in Linux which we can use on files to actually determine files. Okay, to know if this is a text file, to know if this is a born again file, that is shell bash file, to know if it is an image file or that or this. You understand? So with the file utility, the file command, normal file command in Linux, you can see in out the manner of the file command. It is used to determine the file type. Now, the magic file tree is actually used to determine file types. But instead of relying on extension of a file, that is to tell me that this file is an executable file or this file is an image file or a PDF file just by the extension, magic file actually determine type of file by their content. Okay, so that is what magic file is. So looking at this, this is a file used by the file utility program in Unix to identify a file type by examining its content rather than relying on its file extension. So magic file are used in conjunction with the file utility program or the file command in Linux to determine type of file to identify a particular file type based on its content instead of what instead of its extension. And we have different file extension. We have .zip, we have .exe, we have .jpg, we have .png, we have as many as you can talk about. We have .pdf. Literally speaking, looking at this file, probably whatever the file name is, file one or whatever you can call it, looking at these files by their tend to literally say or determine or identify what kind of file this is. But magic file does not rely on extension, file extension to determine what type of file a particular file is. Instead, it works on what? Content. So magic file determine file or identify files based on what? Content. Okay. So now the question now is, how do we create magic file, and how do we use it? So there is a general structure, okay, of how the magic file looks like and how to create it. So now look at what they say here. A structure of a magic file. Magic file contain plain text content that typically follows a specific format, which are defined as rules on each line. Okay. And then the second line always talks about the mime type. Okay. The mime type of the file. Now, there's what we call mime type, which is a short form for, where is that article? When we try to look at what are mime type, is a short form for what we call multipurpose internet mail extension. Okay, so they said it is a media type which indicates the nature and format of a document, file, or assortment bytes. Okay, so they are basically used to identify the nature and format of a document, file, or so. Looking at this in a layman language, they are just used to identify, to tell us if it is a plain text. You understand? If this document contains plain text, ASCII text, born again script, you know, whatever. So that's basically what MIME type is by this in explanation here. So what we need to focus on as far as magic file is concerned is trying to understand the structure of a magic file and how to create it based on their structure. Remember, magic file is identify files based on extent content, not extension. It does not rely on extension. Instead, it what it tells you that this file is this based on its content. So now, its basic structure of the magic file. This is it here, having the first line and then the second line. Now, on the first line, you could see there are different what different texts, all each of them having different meaning. So for the first one, we have offset. Now, what is offset? Offset specify where in the file where it should begin its search, or where it should start looking for a particular file pattern we are looking for. Now, as I said the other time, magic file, it helps you to identify file based on its contents instead of relying on what? Instead of relying on extension. So if you look at this, a good use case of of magic files is that probably you are looking for a particular file. Let's assume um, you are looking for a file that contains the word um, a file that contains the word execute inside, probably a plain text, you understand, or maybe a script. As long as the keyword here, execute, is inside that file. A very good use case is to use a magic file, which what helps to it helps you to find or identify that type, that file, by trying to what do a thorough search on what the content of the file. So it will what it will scan through the content of that file and try to what look for this keyword execute. And once it sees it, what it will return to you that this file contains the keyword that you are looking for. So basically, magic files can be what that can be specific to what trying to look for a particular keyword or set of contents inside a file. So we can run magic file through list of different files, and it will give us description of every content inside a file, trying to what search for the keyword that we have specified. So that is why we now said, looking at the structure of the magic file, we have two lines where we had the um, the first line of the first word on the first line, which is what offset, and it specify where inside the file where it should start looking for the keyword or the pattern that you are looking for. So if we can take a quick recap on um, on the shell project that brought about the magic file of the thing, that is the very last excuse me, the very last task. Okay, if we pay attention to the instruction here, we are to create a magic file, and the eventual name of the magic file will be school.mgc. Okay, now said this magic file should be used with the command file, and the purpose of this magic file is to detect school data file. Now, a typical understanding of this is that the keyword that what this magic file school.mgc is going to search for, or the pattern is going to try to look for in every of the file it searches or it is being compared with, is this keyword school. That is the basic understanding here. So it is trying to detect school data files, that is every file that contains school inside of it. Okay. So now it said it now said school data files always contain the string school at offset 0. So this is clear and explicit, that telling you that the school data files that we are looking for, they're not even on the 10th line of every of the file that we are going to search. They will be at the beginning. Offset 0 means at the beginning of the file, in the content, at the beginning of the content, okay, of that file. That is where you see the string school. Now, for every file that are classified as school data files, don't I'm breaking it down. For every file that we are going to run the magic command or the magic file upon, in order to detect every school data files, they must have the string, this schoo capital letter or uppercase or true. They must have the string school at what? At the beginning. That is offset 0 at the beginning. If we come back to this place, offset means it is this field we specify where exactly should we start looking for the file or the pattern. Okay. Now it said it can be an absolute value. For example, it can be 0, that is meaning from the beginning of the file, just like I said, or it can be 10, that is it has to skip 10 lines from top until the line 10 line. For example, if I open a file in in my, let me, sorry, let me just open this file called C. I have a file here with the name C. You can see it. So if I open with my VI, if I say VIC, now this very line that I am here, I want you guys to, I want us, everyone to focus on this part, and then focus on this part. If I start navigating through this VI file, where this highlight is on line 1, according to what we can see here. If I come down, we have entered line 2. If I come down, we have entered line 3. And if I keep coming down line 4, line 5, line 6, you can see where my cursor is. You can see how it is increasing. So that is what we call offset. That is, when the offset is at 0, we are at the beginning of the line. When it's at offset 2, we are at the second line, offset 3, and so on and so forth. Okay. Now, moving forward, we now have the other one, type. Now, type specify how the data at the offset should be interpreted. That is, what kind of file are we looking for? What kind of file, I mean content, are we looking for? Is it a string content or an integer content or a byte? You understand? So still referring to this, you can see that it says school data files always, they are always what, string content, and that is what the type of the file, still explaining the structure of magic file. So we have the offset, where should it begin a search, and then we have the type, that is, what kind of content are you looking for? Is it a string content or a number? You understand? So now the next thing is, now what are you testing for? What are you trying to detect? So now this field describe the precise pattern, the precise string, the precise symbol, or whatever you are looking for, you are trying to test at that very offset, at that line. You understand? Don't forget, we have different offsets which we can specify that them for the magic file to begin its search. So now test, now this test now is now where what is now where we put our school, because that is what we are looking for. Let me practicalize this with the, let's say I want to solve the task. Let me exit this one. Let me create a file. Let me just create with vi. Vi can create file automatically, we don't need to even do touch. So if I vi school as the name of the file, now I am on line 0, offset 0. Okay, so now what am I, the offset I'm specifying, offset 0, that is begin to search at offset 0. What are you trying to search for? Look for a string for me. Okay, and now after you are looking for a okay, we are looking for a string. Now what exactly, what pattern, what exactly am I trying to search for, or am I trying to look for? That is school, this school with capital letter. Do you understand? So we have the offset 0, start at the beginning of the line, then look for string and test for school. Okay, now when you now see school, you can now tell me, you can say, you can just put description. Description is user based. Description is user based. It's based on, okay, when it sees what we are looking for, what description should it what output. So we can now say, since we are looking for school data file, we can say school data files. So, or school data file. So this is what this man will what will output. With recapping the offset, where you start from, what are you looking for, the type, and then what exactly are you testing for, and then the description. Now moving forward to the second line, this is where we now have, we can see description and an explanation of the file type in human readable form. Okay, we don't want to waste time. Then the next one, he said mime, the mime symbol as a directive to specify the mime type of the file. So obviously, as don't forget, when I came here, I talked about the full meaning of the mime. He said the real work of this mime, whatever. He said it indicates the nature and the format of a document. So we can what, this syntax will, is a default syntax that must be there. And then when eventually a particular file has been the magic file has been operated on a particular file and it's found the school string. Okay, the next thing is now what, is now to specify, is it a file, or is it a text, or is it um an image. This can be user defined. You understand? And then we now what, we can now specify, let's say this, now we are, because of course we'll run this on text, so we can say text, and the mime type is school data. So this is what what this is what will be will be given when we run the magic file. Now, what is needed is to understand the structure and of how to create a magic file. Two lines. The first line contains the offset, the type, and the string we are testing for, with the description when to with the description that will be outputted when we run the magic file. The second line will be outputted also when we add the mime flag to the magic file when we are using it. All of this we understand it very well when we practicalize it, when we run the magic file. So this is just how it works. So the mime is used as a directive to specify the mime type of the file. Now we have this man. The magic file is ready and created already. So we can save. If I cat school, this is what we have. Okay. So now moving forward, let me put the cat school there. So this is what we have. Now let us create two files that we want to test. The first file will contain the school string and the other one will not contain the school string. So we can say cat, the first file, let's call it file 1, and I can just put it contains school. Then the second one I can say cat file 2, and it contains I can say just some random text, and I can save. Now we have the file 1, file 2, containing different text. One contains the school file that we are trying to search for, and the other one contain just random text. Now the next thing we can now do is now to run this magic file on it. Don't forget our magic file is school, right? Now if I follow up with this example, to run the magic file, this is the command. We use the file command. Don't forget, when we are trying to explain the magic file, that is, it is used alongside the file command in Unix. And then we specify the flag -m to tell it that this is a magic file. Then the next thing is the magic file name itself, and then the file that we are trying to test. So let us test for every let's test for every file that has the file name file. Okay, so now can you see for file 1, it said it returned that file 1 is a school data file, and then it returned file 2 that it is an ASCII text. Can you see? And why did it return file 1 as school data file? Because if I cat file 1, it contained the string school at offset 0. Let us do something else. Let me create another file called file 3. Now let me put something at the offset 0, the beginning of the line. Let me put I am a new file. Sorry, I am a new file. Now at offset, in fact, I am a new file. You can, okay, I am just a regular file. Now at offset 0, let's put but I contain school. But I contain school. Let's just save this. At what offset does this school did this school appear? This is 0, 1, 2 at offset 2. Now let's run the magic file on all all the files that we have. Can you see now? See file 3, it has represented it as what? An ASCII text. Why? But it contained the school file, but it did not follow the rule that it must be at offset 0. We are looking for every file that contains school at offset 0 at the beginning of the line. So if it does not begin at if it does not begin at the beginning of the file, then it is not what we are looking for. It will be regarded as a normal file. I believe this is now clear. Don't forget, how do we use run the magic file? We run the file command with the flag -m and then school. Now we can still try to check the MIME type. We can try to check now if we want this line to be displayed, to be given to us. We can now use the MIME type flag on it. So we can do file. I've forgotten the flag. That should be. You can run the MIME type option on it. Okay, it will be file, then MIME type. Okay, and then flag, that is a magic file, and school. Let's run it on all the file again. Can you see? This is saying that this is a text and it contains school. This is a text and it's just a plain file. This is a text but it's a school data file. That's what this thing means. This is just a text but it is a plain file. Plain text. You can see even though that file 3 contains school at the offset 3, but the rule is at the beginning. So now the next thing is, now how can we, because the compiler, if we follow this task, if we are to get our full mark, we need to make sure that we have this school.mgc inside our repository. Or yes, we must make sure that we have it inside. So because this is what the checker will try to look for also. So at that point we need to now convert the magic file school. We need to what? We need to compile it so that it will have the extension school.mgc. So how do we do that? We can just easily do that using the file and then the capital C flag, then indicator that it is a magic file on school. Okay, so when we run this, if I should list the files now, we are going to see that the school.mgc has been created. I believe this is clear enough as far as magic file is concerned. So the school.mgc has been created through this command. This flag here is to compile it in order to have this extension. So that is all about magic file. I believe justice has been made in how will I say it? So that's about magic file. Okay, Abisola, I think that should be a clear a bit, right?
Yeah, yeah, yeah. So, so,
Okay, any other person um concerning the previous project, probably 3 days ago or yesterday or
please,
today?
I don't know if we can look at Markdown or something like so. I look at somewhere
Okay,
Markdown
Markdown.
first.
So
Yeah, I know it
that's
benefits everybody, but I'm not understanding that thing. So
okay.
we can look at it later.
Let us start this way. So Markdown text. Actually, they are used it. This is it here. So now markdown text are just, let me give the description here. Let me don't use my own explanation yet. You can see markdown is a lightweight markup language used by for formatting text. Have you wondered why every time you create readme, you always do echo? Let's say you are creating a readme file, you always do echo my first readme file, and the next thing you are creating it inside, you will say readme.md. Have you ever wondered why the md is always there? The md simply means markdown extension. So they are just, you can see it is used for writing documentation. So it is as simple as that. Example of documentation like readme files, forum posts, you know. So, and they have their different words, syntax inside, that indicates each level of text that it transforms. Okay, each text that you put inside. For example, look at my GitHub page here. Look at this is my readme.md, and now I have this description here. My first line, ALX engineering. Why is it big like this? It's because I formatted it using one of the symbols, or one of the um, syntax, one of the markdown syntax, which indicates its meaning. Look at what we have here. Now, this is for title. If you have actually worked with HTML before, we have different, we have heading. We have something called heading in HTML, okay? And we have syntax that identifies headings. If you want to write, okay, if you go to a particular site and you see a big heading trying to like welcome you, say welcome to our website, or something like that big text that you see. So most of the time they are actually formatted using the HTML heading syntax. So we have 6 levels of heading in HTML from H1 to H6. You understand? And H1 is the highest. So in HTML, we have the opening tag, and then we have the closing tag. You understand? So for this HTML element, we have, for HTML this heading elements, we have the level 6 levels from H1 to H6. Now we are not talking about HTML, we are talking about markdown. Same thing applies to markdown. Okay, for markdown text, if you want to have the biggest heading or title, which is H1 in HTML, but you understand, that is when you have the hash, a single hash, then space title. Then if you have double hash with space, it is regarded as the second level heading, which is smaller than H1. This one is the third level heading, which is smaller than H1. You understand? So this is how they have different syntax. You understand, that format each of the text that you create. In HTML we have different elements. We have the paragraph element. You understand? We have the italics element. We have the break element. We have the underline element. We have the bold element. Each for formatting different text. We have the link, anchor. You know, like that. So the same thing applies to markdown text. Each of them having different word syntax. You can see for this is for headings, just as it is. When it is a single hash or pound, is level 1, and you can see the different levels. You can see 6 pound means it will be the smallest. All right. So, and there are other things here too. It's just for us to study the markdown. There's no big deal there. It's as simple as what we have. as something that can be easily taken. Okay, so that's about Markdown. Okay, any other thing? Okay, let's go to today's. Let's see what we can achieve today. Now, okay, let us look at something. Let us look at this concept. Let us look at shell variables. Okay. Now let's say we want to create a script that's actually, what does this script does? What does it do? The script is to greet a user, asking them their name. Okay. Then after it asks them about their name, the next thing is that the user will have opportunity to input their name. Then after the user has been able to input his or her name, the next thing is that this script will greet the user and say hello by the name of the user, the name that the user inputted. So I threw a challenge to the group the other time where I tagged it as challenge one, part one, challenge one, where we have, okay, this is it here. He said, how do you create a shell script that asks the user to enter their full name, asks the user to enter their year of birth, and then the shell script does the calculation on this year and then return it. Now it now prints to the screen, you are welcome, and the name of the user, and then it prints to the screen again. So you are the age of the user. Probably the user is about 44 years, so it will be like you are 44 or you are 32. So this is basically how can we create something like this. Now, the essence of this, why I actually chose this in order to share with us, is that there are some things that will be learned in this script if we eventually create it, and it will serve as a pointer, and it will serve as how will I say it? It will serve as an entry point for to give us understanding about how C program works and programming language works generally. Okay, so this time around we are trying to create a script that is kind of interactive. So now let me copy this tags and let's see how we can come about it. There's a noise coming from somewhere. Oh. Okay, guys,
Brandon or something. I think it is
that's what I'm
Brandon.
trying to do. The noise is okay. I've been able to mute it. Okay, now before we dive into that, I was on something. I don't want to mix it up, please. I was on shell variables. Okay, shell variables is something that we will eventually automate, just like every programming language. I don't know. We should have heard about variables before. You understand? As far as programming is concerned, there are concepts like variables, constant, string, data type, you know, that operators and so on like that, that we, of course, we will always meet. And it is necessary that we have understanding of what these things mean. Now, the first thing among them is variables. As it is that there are variables in C language, also there are variables in Shell. Shell itself is a programming language. Okay, to break this down, To be explicit, shell itself is a programming language and it can be used for scripting and for automation and so on like that. Okay. Now, what are variables? Variables are just like identifier, anything that can be used to identify anything. You understand? So, and one thing about variable is that they change. They have the tendency to change their value to change at the end or during the course of the program. Another definition is that variable can just be, you can just call it like anything that can serve as a container to hold values. Okay. So, for example, if you want to, you can, if you want to store your clothes, okay, you need to store your clothes in a bag. You understand? In a container. And that container, we have a name, we can call it a bag. You understand? So name, the variable we are talking about here is a bag. And what is its purpose is to for what? For storing your clothes. Now, do you know that the value of, okay, let me make it interactive. Let me project everything I'm saying. You know, you can see variable, variable like a container for holding or storing values. You understand? Example for illustration, a bag, okay, for storing what? You can for storing clothes. Okay. Now, do you know that we can actually change the value of this bag by what? We can still have a bag that can really what store, we can use it to store probably books, you know? I don't know. So what matters here is that variables are just like identifiers or anything used to identify an entity, either one is too big or data, or just used to identify or an entity, data or values, or used to hold values or entities or data. So that's basically what variables are. So one thing about variable is, characteristics of variable is that they could change, their value could change. You understand? So that's what makes variable different from constant. When you say constant, constant means something that cannot change. That is, it is the way it is. You know, we have in mathematics we have constant values. When we say pi, pi is always 22/7 or 3.14. So it's a constant value. But when you talk about variables, they can change. The values can change. If you talk about age of a person, of course, age of a person can change as the person what, as person grows or as time passes by, the person's age changes. So example of variable like that. Just understand very basic concept. Variables, anything that holds value and they have the tendency to change, have the tendency of changing its value. Okay. So now the same thing happens in shell. You understand, where you can have variables. Now, variables are often or obviously needed in order to what, to program, to carry out program, or to read write program, or to execute any operation. You understand? You know, computer as it is it base for you to call a computer, three things must be available, where you have the input, the process, and the output. So when you talk about input, okay, there must be an input, there must be something that must what, must be given, and after that there must be an operation process that must be what, that must happen, and after that there must be an output that will be given to the screen. For example, if you talk about how do we write a program that adds two number, okay, a program that adds two numbers. So obviously, if we break that this down into algorithm, we must have number one and then we must have number two, two numbers. And of course, we are talking about what the operator that is needed to be used here. We are talking about addition, okay, which is the plus operator. Excuse me, the plus operator addition. Then for this to make sense, we don't just want to add and then add for adding sake. There must be a result. So we must have number one, number two, then we have what? Results. Or we call it sum. So there is an input that is needed and there's another input that is needed. Now there will be a process which will be what? That will be applied. Sorry, this process operator will be applied on the number one, number two, and then what? There will be the output, which is the sum. So the essence of variables to hold values. So now, um, in shell, okay, or in batch scripts, unlike every other program, variables are identified with the dollar sign. Okay, any value, okay, or any entity that has the dollar sign begin at the beginning of it, it is regarded as a variable. We can have the something like part variable. We can have a variable that we created, user defined variable name. We can have um, we can have number. We can have age. You can call it anything, you know, it working directory, user, home directory. These are even default shell variables. You understand? This one that are in capital letters. So what are we trying to project here? In shell, variables are identified. In shell, variables are identified what? They are identified by the dollar symbol. All right, symbol. So now the next thing is how do we create variable in shell? It is, in fact, for me it is pretty simple, like the simplest thing. And now I want everybody to like have how will I say it? This is a suggestion for me. Okay, I want everyone to like have more interest in the shell, the likeness, trying to understand, trying to manipulate and do a lot of things. To be sincere, if one can be able to understand the shell very well, you see Python programming language would be very, very easy. And of course, we have been told that if we can understand C programming language, every other language will be so easy. So I'm not even talking about the shell. Of course, understanding the shell, you'll be able to understand the C programming language because the C the C language is closer to the machine level language. And in fact, some of the things used by the shell are actually used in in C2. So now we're now moving forward to Python. It will be so easy. Okay. So how do we how do we create variables in shell? It is just as simple that you just have the variable name equals to no space. You know, you can say name equals to Shelby. That's just it. Now, this is just the basic way of creating variables. Of course, we will not forget that we are writing a script. There must be this man that must be at the top of every of our shell script, the shebang. Okay? So if we say something like this, shebang or ashbang in bash, then proceeding this way, we have started creating variables. And how do I target variable? How do I get reference? Okay, that's the keyword. How do I reference a variable? I can just say echo, and then for me to reference the key the variable, I can say echo hello, and sorry, this is a normal string, and I can reference the variable name, and this output will be hello Shegun. Sorry, this thing is not correct. So it will be this way, hello Shegun, according to what this formula that has been given here. So obviously, variables can just be created with the variable name equals to and then its value, and we can reference it by what, adding the dollar sign to what, to to the given name that was specified, to the given name of the variable. All right. So now a brief crash course. There's something we call data type. You understand? Of course, when we start our C language series now, everything will become easier for us. So I want our C study to be a series, and probably we could be starting tomorrow, so we can we can be able to follow up like that. And if we want to go back to the video, it will be easier to check the content. So we have data type in 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 programming. Probably many of us are familiar with it. Of course, for every data, they have it, for every data they have their type. You understand? If we say number, number is a type of data. If we say string, string is a type of data. And then we can have different kinds of string, name string, you understand, text string, and so on and so forth, like that. We can add different kinds of number. Okay, so what matter most is data type. So data type are basically different types of data. You understand? Because data as it is, they must be stored. They cannot just be an abstract entity like that. They must have what, a particular way of identifying them. Okay, so we have different data type. We have number, we have string. Okay, we have character. Let me give you an example. We can have a single character. We can have a etc. Even symbols are, as long as they are character, and we can have string, you know bash, you know street, and so on like that. And we can have number. We can have one, two, three, four. And you believe me, we have, let me just put the range from 0 to 9. We have different type of number. We have floating point numbers too, where floating point means numbers with what, decimals, number with decimal values. Okay, we have 3.14, 2.2, whatever you can talk about it. So we are just trying to digress and make everything easier. Of course, every variable must have their data type. For every variable, you must be able to identify what type of data is this variable holding. So variable holds data, and by default, the type of data that the variable holds help us to understand that type of, what kind of variable that variable is. So looking at this man here, we have name Shegun. Looking at this, obviously this variable name is holding a string value. So the data type of this variable is a string variable. Looking at this variable age, it is holding a value 22, which is a number. So the data type of this variable age, it is what? Obviously a number variable. You know. Now I talked about number here. I talked about from 0 to 9 and normal, upwards. Sorry, if you combine them, combinations, and then we talk about floating point numbers. No, now when it does not have, when numbers does not, when we have numbers which does not have decimal attached to them, then they are known as integers. You understand? Integers are just single, are just plain numbers, real normal. How will I say it? The normal numbers that we see from 1 to 0, 1000, 2000, 30,000, as long as they don't have decimal points attached to them or decimal values. Okay, so now we just digressed. This is where we are talking about. Now, how do we now create this script? I think I've been able to talk about the basic thing. We talk about variable here. Now, there is now another command in shell. We call it the read command. So the read command in shell is basically used for receiving inputs from the user. So that is the basic function of the read command. And how is it used? So general syntax of the read command, we have read, okay, then variable name. Because when you use the read command, you must actually make sure that the read command is when it prompts the user to enter a particular value, it must store that value inside a variable. So that's why we have the read command and what variable name. So I can do something like this. Sometimes when you just do read, if it collects, okay, if it collects value from the user, if it prompts the user to input value and we don't specify a place to store it, it will just prompt the user and there won't be anywhere to store it. Okay, for example, if I say read, look at, I have sent the read command on my terminal and now it is what prompting the user to enter. So I can say I am entering this prompt, and that's just it. If I ls, there is nowhere, no place it is being stored. It is not stored anywhere. But let me do something. Let me say read name. This, what is this going to do? It is going to what? It is going to um, prompt the user for a value, and the value will be stored inside this variable name. Obviously, I cannot say we want to ask the user to input the name, but normally it's just a normal variable, but by the name of the variable we can say that this variable is trying to collect name from the prompts. Yes, but basic understand that is needed is here is that we are using this read command and on this variable, that is whatever prompt the user enters after the read command has been what executed, it should store that value inside this name variable. So if I say read name, I can say Bamidele Michael. And automatically, this input has been stored inside this variable name. How do I check this variable? How do I get it? If I list file, I can't find it there. But when I do echo dollar name, you can see automatically it has what? It has given me this value. So automatically, this name variable here has been stored in the variable path environment of the shell environment.